I'm, this is the Laser Synth, a device for assorted lunatics. My name is Cameron McLaughlin, also Scoots, but everybody calls me Cam. And let's get right to it. The Laser Synthesizer. So, what you may be wondering to yourself, this is probably you. What the heck is a laser synthesizer? So, short answer, it's just getting sound out of light. When you boil it down to it in the most simplistic terms, I am dealing with light that carries sound, pretty much. So I took photonics, if you consider electronics being the controlled motion of electrons, while photonics are the controlled motion of photons, lasers and optics. And then I took the synthesizer, something that produces and manipulates pure electronic signals for a musician to kind of sculpt their own tone out of, with the first successful model being the Moog modular. I mean, I know there were lots of others, like, the Buchla and stuff, but, Wendy, Carlos, and Moog pretty much, helped standardize that. And it revolutionized music in production in the industry, and it stands as a testament to being the iconic sound of the future. So I combined them together. I took the photonics, the lasers and optics, from it, and then I took the synthesizer, the manipulation of signals, and then I made the laser synthesizer. It manipulates laser optical signals, so, you get sound out of light, pretty much. So we started off with the R&D of the, synth, mainly with the research. The Pepe Sylvia GIF is a good representation of, the rabbit hole you fall down. From humble beginnings, it all started with this sketch pretty much more than a year ago. This is all the applied photonic, photonics and all that stuff. And it is based solely around audio modulation. When I was researching this initially, there were no studies, scholarly papers, patents existing for this, and I checked thoroughly, and it came up dry for the most part. So I didn't know where to start, but I knew this was some sort of sound of the future I could work on. So, so I mess up with the slides anyways, just because I think that's funny. But we go on the search for knowledge. I fall down a rabbit hole, and you see my face of insanity, hand printing and just sort of handwriting all my notes and studies and papers that I found trying to piece this together. And all of that led to the design of the laser synth. This is where the magic happens. And so I have my obligatory, college lab takeover, and the classic candid shot with your synth, as did Robert Moog back in the day with his creation. And then what my goal was I wanted to create a product that would emulate the hands-on intimacy with vintage lab equipment from the 60s up into the 80s, pretty much. And I feel like it's something I could challenge myself with by sticking with pure analog design in a way. So it's like, all simple components, no digital shortcuts or computer algorithm controllers used to process my audio. And I want to make all these analog electrical systems hold up the photonic and laser stuff on a pedestal, pretty much, and basically be the backbone for it. And overall, avoid making a electronic synth with a optical facade, pretty much. Like those laser harps, pretty much, where you just break a beam and that instrument plays a note whenever you, block a beam light, which, sure, it is a laser instrument, but the laser itself isn't carrying the audio signal. So first things first, in my lab, I had to design and build a whole synth rack from scratch using guitar pedals and a old piece of RF equipment, a equipment rack that I modified just for it with an oscilloscope from 1970 that still works miraculously. Whoa. And then we go into the main panel design. So this is the actual synth, and I went through 3 main iterations, but I settled on the third one. And you notice that the electronic to photonic side on the left, that's where you input your electronics and audio signal. And then in the middle, this is where your photonics are. So this is where you take your laser audio, the sound laser, and you can just sort of create patches using fiber optic cables. And then all the way on the right, where those dials are, that's where you can take your laser light signal and convert it back into an electric one to play out a speaker. And I specifically designed all these electronics to emphasize the photonics and not, you know, take attention away from it in a way and sort of act like an impedance matching network to it. But I think I'm getting ahead of myself here. Regardless, I also worked with a eighth-inch acrylic panel design where I did cutouts and little symbols that I designed representing each photonic circuit, like directional couplers, ring resonators, the Mach-Zehnder interferometer, and I made them all like snap in together like Legos as well. And it was a lot of fun to do once you got the measurements right. And then, of course, the electronics are important. I basically found out that the equipment in my lab that produces the lasers and converts electric signals to laser ones, they are not designed for audio and it sounds noisy, and that's why in my previous video it sounds like crap because it's not impedance matched at all, and the frequency response is getting way too many supersonic frequencies, and that's not good. That basically means, like, because this is all this laser stuff is designed for, like, like RF stuff. So it's like, you hear about, like, fiber optic internet being fast and stuff, and it's like 5G networks. So it's basically just something that is meant to handle something way faster than something that is audible in a way. So I basically took the philosophy of 70s analog high fidelity stereos by hand designing and hand measuring all my components while also being reliable and repairable at the same time. And then I took the time to use eighth-inch birchwood to make the enclosure for everything with an interlocking panel design. And also, for the record, I used a synth, a laser cutter, to cut out all these pieces, so a laser made this laser synth. Put that in perspective for yourself. And then this is the final render. It's all sort of beautiful looking, kind of combining everything. And basically, this was all single-handedly done besides a touch-up from a good artist friend of mine and just some basic consults for just, fine-tuning the design to cut out. And that was it. And this is the big foreshadowing for the, companion video with this. Why did I do all of this? Because I felt like it. Simple as that. I applied myself completely with all my skill sets, both self-taught, school-learned knowledge, used such as drafting, CAD design, rigorous research, the mathematics, electronics, mechanical, designing stuff in parallel. I'm not sure if I pioneered an industry from scratch, but I may as well have. I don't know. So this only scratches the surface, though, because my prototype and the photonics are still expensive, fragile, and fickle to manufacture because the experimental photonic element I'm using is like $5,000, and it is about as fragile as it gets. So you can't really make any money off this design. And I desire to, keep this whole thing open source, though, to breed more innovation, since this is the case with the electronic synth market. I want to see people make stuff out of this and not feel constrained by it anymore. And I didn't make this for profit or fame in mind. Again, it's only because I felt like it. And this video is just sort of to get this idea out there, which is why it's informal. I don't really care about it because, like, if it takes off, it's just going to, you're all going to have to embrace the stuttering I'm doing and stuff because I really don't care about editing this anymore. Where was I? Yeah. I made this out of the raw pursuit of knowledge and passion I have for vintage electronics, which carries on to my aesthetic of cassette futurism, which is kind of the main driving force. So I kind of made something that would be seen in a universe like, Ridley Scott's Alien from 1979 with the Nostromo panel, all this analog equipment, CRTs, no digital reliance on digital systems, and it's kind of like a beautiful symbiosis here because everything just feels so tactile and hands-on, and you just sort of feel like and you see like the actors sort of interacting with it just like seamlessly and casually, just sort of getting a good feel for all the switches. And then because this all comes from an age of electronic engineers having to solve both electrical and mechanical design problems for equipment. So they ended up being incredibly rugged and very integrated in terms of design and the form meeting its function. And I really appreciate that, and that's why I really love vintage lab gear and using it in my work. And then carrying on with the Alien movie, I also, use the semiotic standards for the fiber optic system or the photonic system from the movie Alien. And the movie definitely heavily inspired the design of the laser, especially Rob Cobb's work on this, on his like semiotics that he made for the movie. And it encouraged like unique artistic flavor while remaining industrially streamlined in a way. And it was definitely a important starting point because I wanted to find a way to make something feel slick and something that you would find from that movie, pretty much. Like if you saw that on one of the terminals in like the Nostromo, you wouldn't bat an eye at it. Or you would, I don't know. I'm not your mom. So then I need an artist for this. So this is where my Wendy Carlos comes in. Lemenza. Um, he's the one who's kind of helped me hone in and focus on my artistic direction. He's the one who's actually made the initials of ours on the top right there. And it is a phonetic spelling of an entire language he made on his own, pretty much. So he paints in MS Paint with an old computer mouse. Like, he made that piece on the right. And if you look closely, it is just all splotches of like paint that he all just slapped together into a incredible mosaic. And he is like got to a point where he got like an offer for like exposure from Microsoft, blah blah blah, at the cost of his ownership. But you know what? Like at the end of the day, though, he turned it down publicly because he wanted to kind of keep that creative freedom close to him. Like he is definitely like one of my go-tos for design because he is a innovator driven by an attention to detail, passion, and he's untouched by monetary motives and conflicts of interest in this. So we both kind of want to keep this open source, and what's a better way to do it than literally making a diegetic diagram of it that you would see in the movie Alien, or like I've also heard Star Wars too, like 70s sci-fi. And it's all so Lamenza, he drew up a vector drawn diagram for pitching to companies of fabricators. And since this language is unique in of itself, and it's also consistent for the diagram, only two people can translate it, me and Lem. And I think it's not going to be easy for anybody else to translate it because there's also red herrings in there too, and I only know where those red herrings are. And it shows a deep level of appreciation for my vintage aesthetic, as well as just my overall vision for the project. And it's a way to sort of help normalize engineers working more with artists to kind of push the limits of sort of form and finding ways to collaborate and in sort of combining it with the functionality of your product. And then at the end of the day, what is a laser synth good for? So I'm trying my best here to set a bar, the standard of optical photonic synthesis and modulation, through the semiotics, since none exist. I had no preconceived notions of what was right or wrong, so I had to basically make it up as I go along. And I want to have the ability for musicians and other audio techs to take my foundation and just innovate further, just as with the electronic modular synth, user-oriented design and modularity, and my semiotic standards to kind of make something of its own, something that is like a new breed of analog synthesis that is literally at the speed of light, and it has a lot of things that I'm still researching right now could break a lot of limitations in analog synthesis that you can't do electronically. And this is the ground zero. This is proving it all works. It was independently built with love, fine attention to detail, and raw tenacity. I'll link this in the description below because God, if you listen to this with your eyes closed, God help you. So once you free your mind about a concept of harmony and music being correct, you can do whatever you want. So nobody told me what to do. and there was no preconception of what to do. That was Giovanni Giorgio. The song that this comes from, it goes insanely hard. And I was listening to it when I wrote that too. This project is my brainchild. I'm happy and satisfied with my work. No matter if I come out on top or bottom, famous or rich, or just, remain niche, I only wish to share this work with the world and continue pioneering this sound of the future. And if you have any questions, comments, and or non-complaints, please let me know in the comments below. Get the funny little complaint department. Thank you for watching, and I really hope this gets somewhere. And I'm keeping this. I'm not editing this either, or editing out all the stuttering. I'm keeping this in, so I mean it. Man, that was weird. Okay, see ya. If I can stop recording.